Hello guys and welcome. Today we're going to go over a popular array problem here, and this is called the water collection problem. So the idea is that we're given an array of different numbers, each representing a certain elevation, and we want to find out how much water can be trapped between the elevations. So here's a little visual of what I mean, and the idea is, as you can see, we've got maximum height here and maximum height over here, but the water can only go up to the height um, of the minimum maximum that we see over here. If it were to go above, then we'd have an overflow. I would pour basically this amount of water into the next pool or the next pit of water over here. As you guys can see over here, here's another little pit that's been created. And we can ignore the names of these different places down here. The important part was kind of figuring out what a visual for this problem looks like. And yes, the water here is not very healthy because it's an aqua color and it looks kind of sickly, but we'll ignore that for now. Okay, so now that we've got a general idea of what it looks like, here's how we're going to figure it out. Notice how last time what I mentioned was we have maximas to the left and the right of water here, and we've got a left maxima and then a right maxima. This is very important to keep note of because we're going to use maximas to trap all the water and count how much water has been collected. So now that we figured that out, um, we want to somehow keep track of maxima for each elevation. So we could use plenty of different data structures, but the most simple data structure to use is an array itself. And each one of the arrays is going to be the size of, well, our original array, because we need to keep left maxima and right maxima of each individual spot. So, and then the way we get the amount of water that's collected, well, the water that's going to be collected is going to be equal to, say, for this spot right here, the amount of water that we could fit, for this certain block would be basically the smallest maxima to its left and its right minus its current height. So in this case, the amount of water that we can trap from the 6.4 to the 4.0 block here would be about 2.4 units of water. Now that could be feet, that could be meters, that could be inches, that could be centimeters. It's whatever you want to envision it as, whatever makes it a little easier to understand. So now that we've got a general idea of what we need to do, I've written up some pseudocode here. As you guys can see, the input is going to be the array of elevations. The output is the amount of water collected. We start off by saying that we need to create two arrays, keeping track of the left maxima and the right maxima. They're both going to be the same size. And the amount of water collected at the start is 0. So the first thing we know is um, the leftmost elevation point here is already its local left maxima. There is nothing to the left of it, so it is the maximum of its left side. Now for the right side, the rightmost element in the array here is going to be its right maxima, so we can just kind of set up the rightmost maxima to be equivalent to whatever its elevation is. So that's why these two lines, that's what this line here is doing. Then what we do is we run a loop to find out what the left maxima is. We keep track of the previous left maxima in our array, and we compare it to our current elevation to see if we have a new maxima. And then we do the same thing with the right-hand side, except instead of going from left to right, we're going from right to left. After we've collected the data on the left and the right maximas for each individual point, what we do is we continually add positive water values to the amount of water that we've collected. And, oops, this should have been math.min, not math.mind. But basically the idea is we take the minimum left from the minimum of the left and the right maxima, and then we subtract the elevation from it, and then we return the amount of water collected. So, to show you guys how this works, I've already compiled and run this program. But the idea is, if we take a look at this first array, our in between 3, 2, and 4 is considered to be a pocket here because 3 is greater than 2 and 4 is also greater than 2. So 2 is the bottom of the pocket, and that contributes 1 unit of water. Now if we take a look over here to the other side of this, we've got 4, 1, and 5, and it just so happens that 1 is the bottom pit here, and we can't trap more than 4 units of water in this little pit here, because if we do, then what will end up happening is we'll get an overflow into the other pit, and then it'll be all wonky and weird. So in this case, we should produce a result of 4 units of water collected. Now, following the same sort of logical pattern here, for this array, we should produce 8 because from 6 to 2 here, we get basically a drop of 4. And then from 2 to 4 over here, we get a drop of 2. So that's 2 over there. Now 4 to 1, you'd think that, oh, hey, that would add a 3, so then we'd be at 7. Why 8? Well, the idea is it just so happens that the leftmost value here and the rightmost value here happen to be the ultimate maximas for each individual spot here. So what we need to do is we take the minimum of both of these maximas, and that's going to be 5. And then basically what we do is for these next 3 values here, we subtract each one of their values from 5 and collectively add it to our overall result. So if we take a look at the 2, we do 5 minus 2, which gives us 3. 5 minus 4 is 1, so now we are up to 4 units collected. 5 minus 1 here is 4, so then we get a total of 8 units collected. So I've already run this, and I've already tested it a couple of times, and you guys can see the results. But just to show you guys that it works the way that it's expected to work, we're going to compile this one more time, and then we're going to run it. And as you guys can see, the amount of water collected for the first one was 4 units of water, and the amount of water collected for the second one happened to be 8 units of water, which is exactly what we were expecting. So I hope you guys found this video useful, and we'll see you guys next time.